Hello and welcome to our lesson on linear functions, graphs, and slope. This is going to be from section 2.5 in our text. In this particular lesson, we're going to be looking at finding the slope and the y-intercept from an equation. We're also going to be looking at finding the slope of a line containing a given pair of points on the line. So here we go. Before we jump into the examples, we've got a couple of formulas we need to look at. The first formula is the slope-intercept form. Slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. So just to make a note here, m, whatever the value of m is the slope, and b would correspond to the y-intercept. Now, as an ordered pair, the y-intercept would be 0, comma b. So just so you know, the y-intercept is a point, and therefore it should be written as an ordered pair, but this number, b, whatever it is going to be the y-coordinate of your y-intercept. Next, we have the slope formula, which says if you know 2 points on the line, you can calculate the slope of the line. So your first point would be your x1, y1, since an ordered pair is an x comma y. And your second point would be x2, y2. And it doesn't really matter which point is the first point, as long as you keep the x and the y from the first point as x1 and y1. And that should be it for introductory stuff. The first example we're going to look at here is number 5, where they give me an equation and the instructions say find the slope and the y-intercept. So it is important to note that this equation is in slope-intercept form, and you can always tell if you're in slope-intercept form because y has to be by itself. So since we're in slope-intercept form, if we grab the coefficient of x, that will be our slope. The other number here, the negative 1/5, that is going to be our y-intercept. So depending on how they want you to input this, maybe you're doing this in MyLab Math or whatever, you could say m is negative 3/8 because m is the slope. And then you could say the y-intercept is the ordered pair 0, negative 1/5, because normally the y-intercept needs to be represented as an ordered pair. And that is it for that problem. That is finding the slope and the y-intercept. Okay, for our next example, number 9, they want us to find the same stuff. Here they want us to find the slope and the y-intercept. Notice the difference between this example and the previous example. Notice the y is not by itself. And so if I want to find the slope and the y-intercept, I need to get into slope-intercept form, and that means I need to get y by itself. So the steps that you go through in order to achieve that objective, first we need to isolate the y term. And that means that the 2x term needs to come over. So we'll have negative 3y equals the 2x when it comes over makes it negative 2x. The 8 is understood positive, so that's plus 8. And then the next step is to get rid of the coefficient of y. So we're going to divide by negative 3, everybody separately. You divide every term separately by negative 3, and that is going to get us into slope-intercept form. All right, now look at this. I've got a negative over a negative makes that a positive 2/3 x, and a positive over a negative, overall, that's a negative 8/3. And I'm done. The coefficient of x, that's my slope. the negative 8/3, that's my y-intercept. And again, depending on how they want it, you can say the slope is 2/3, and the y-intercept as an ordered pair, 0, negative 8/3. And that's going to do it for problem number 9. Next, number 14, I thought we should look at a problem like this because this might be a little intimidating for some people because it's not slope-intercept form, but it's also not standard form like number 9 was. Okay, but if you're trying to find the slope and the y-intercept, you do need to get y by itself. So watch how we get y by itself here. First, I'm going to take the negative 10 over. That's going to make that 5x plus 10 equals 2/3 y. Now, in order to get the y by itself, at this point, I've got to get rid of his coefficient. I've got to get rid of the 2/3. You can either do that in 2 separate steps, or you can do it in a single step if you're, mathematically skilled. So I think what I'd like to do, I'm going to show you how to do it in 2 steps, okay? That might be the less stressful way to show how to do this. So if I was going to do this in 2 steps, I would say, okay, I've got a fraction. I don't really want to have a fraction. So to get rid of a fraction, you multiply by the denominator. But whatever I do to one side, I have to do to the other. And this 3 here is going to distribute to every term on this side. So again, I'm doing this in 2 steps. I'm going to get rid of the fraction first, and then I'll deal with this 2 here. So we're going to have 15x plus 30 equals, now these 3's canceled, so that's going to leave me 2y. And then I can get rid of the 2 by dividing everybody by 2. And this may take a little bit longer than getting rid of the 2/3 in one step, but it may be a little less stressful too. Maybe a little bit easier to understand. So now notice I've got the y by itself, and so I'm going to write the y on the left. You can do that. You can flip this around and say y equals 15 halves x. 15 does not divide by 2 nicely, so I'm going to leave that f'd up. I'm going to leave it fractioned up. And 30 does divide by 2 nicely. That's going to be a plus 15. And at this step, I'm done. Once you get that y by itself, then you can see the slope and the y-intercept. So here the slope is 15 halves, and the y-intercept, remember as an ordered pair, would be 0, 15. All right, for problem number 23, our next example, here they have given me 2 points on a line. The instructions say find the slope of the line containing the given pair of points. So what I'm going to do here, since I'm going to need to find the slope, is I'm going to need to label these coordinates. So the 9 and negative 4, I'm going to go ahead and label that as x1, y1, because that's my first x and my first y. 3, negative 8, that's going to be x2, y2. That's my second x and my second y. And now that I have those labeled, I can go to my slope formula and plug and play. So the slope formula says in the numerator, y2 minus y1. So that's going to be negative 8 minus negative 4. y2 minus y1 all over x2 minus x1. x2 minus x1. And then I just need to simplify. Okay, so check this out. A negative and a negative here make a positive. That's going to be -8 plus 4, which is -4. 3 minus 9 is -6. A negative over a negative makes a positive. Hey, 4/6 will reduce. And so you need to reduce that to lowest terms. And so there's your slope. That's it for number 23. That's all they ask you to do is find the slope. But as a bonus, I'm going to throw in another nice little fact that you're going to need to know later is, hey, guess what? Slope is rise over run. You may have heard that before. Most of the time when you're graphing, which is our next section, you're going to need to know rise and run. And so slope is always rise over run. And one of the cool ways that I like to remember the numerator are the y's, and the y's are the rise. Look at that, it rhymes. The y's are the rise. Hey, that can also help you remember that the numerator are the y's. I don't know. Just thought I'd throw that in for fun. Now, for my next example, the textbook didn't have what I wanted to show you, so I'm going to call this my first example. This is my number 1, and this is going to work out kind of interesting. Here we want to find the slope of the line containing this pair of points. So again, if we're going to find the slope, we need to label our points first. Label your points first, then plug and play. And remember the y's are on top. So that's going to be y2 minus y1 over x2 minus x1. And then we need to simplify this. Okay, so again, notice up top, two negatives make a positive. What is -3 plus 3? Uh-oh, that's 0. And in the denominator, 0 minus 4 is -4. And then you're going to have to simplify this, okay? So when 0 is in the numerator, what is the outcome? Well, 0 divided by any non-zero number is 0. So here, this slope is 0. And again, just to give you some good stuff here, any line that has a slope of 0 has to be a horizontal line. This is not part of this actual lesson. I'm just giving you extra stuff for free, okay? At no additional charge. And I want to prove it. I can prove this. Let's plot these points. 1, 2, 3, 4, -3, and 0, -3. Notice if I plot these points and play connect the dots, look at that. I get a horizontal line. How much slope does a horizontal line have? None. It doesn't have any slope. And so that's why the slope is 0. Here, I have another pair of points that are on a line. And again, this is not from the text because they didn't have one like I want to show you. So this is my second example. And we need to find the slope. So what do you do first? Label your points first. Always label your points first. And then we're going to plug and play into the slope formula. Y's up top. That's going to be y2 minus y1 over x2 minus x1. And then I need to work that out. Okay, again, two negatives make a positive. 4 plus 3 is 7. But this time in the denominator, 5 minus 5 is 0. OMG, what happens when the denominator is 0? Well, it turns out division by 0 is undefined. Anytime you end up with a 0 in the denominator, that slope is going to be undefined. Now, what does that actually mean, undefined? Well, it definitely doesn't mean no slope. Undefined is not no slope. 0 is. 0 is no slope. So let's look at what undefined means. And to answer that, we're going to go to the graph and we're going to graph these points. 1, 2, 3, 4, 5. If I go to 5, the first point is at -4. And the second point is over 5 and up 3. Now look what happens when I connect those dots. What kind of line is that? Well, that is a vertical line. And guess what? A vertical line has a lot of slope. In fact, a vertical line has so much slope, you can't even calculate it. That slope is undefined. So what I want you to know there is that undefined means a vertical line. And anytime the 0 is underneath, it's undefined. Can you remember that? Underneath, undefined. And I believe that's going to do it for this particular lesson. So if you have any questions or comments about anything I've done so far, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.